looks better. Okay, like I said, this is chapter 8, classifying features. Learning objectives, talks about just generally know what to consider when classifying quantitative attribute data, become familiar with classification methods, choose symbology based on classification type, create dot density maps, create graduated color maps. An important aspect of using an arc map is to decide what data to map and how to map it. You just worked with qualitative data in chapter 7. In this chapter, you work with quantitative data. Common examples of quantitative data: the population of a country, area of a city block, and the length of a hydroelectric transmission lines. Quantitative maps show numeric values in relation to one another on a continuous scale. Although you can map individual values, it's often more useful to group or classify these values. This will help your readers separate the data visually so it can be understood more easily. I talked about the different mark map can create several types of quantitative maps. Graduated color uses a change in color to represent data classifications. Graduated symbol map uses a symbol that varies in size to represent numeric attribute values. Proportional symbol map, similar to the graduated symbol map, except the symbols are drawn proportionally in size. Dot density map represents quantities using randomly placed dots to form a density pattern inside a polygon. Okay, so this is on 263 now. And it says when mapping quantitative data, you want to classify the data appropriately to the information that's not skewed or misleading. ArcMap has 7 classifications methods. Then on page 265, we're going to open EX08A. Now this opens up our map. It says the map is open data view. It contains a single data frame called Texas. It contains the counties layer. You'll explore the layers attribute to gain an understanding of what you will be mapping. In table of contents, right-click the counties layer. And click Open Attribute Table. And this looks like gives us all of our different counties. Population per square mile, guessing. Table contains many attributes such as county name, population, crime data from 1994 and 2002. Close attribute table. In table contents, double-click the counties layer. To open the layer properties dialog box, click the symbology tab. Mine's already selected, but if yours is not selected, click symbology. Under show, click quantities. Show. I don't see show. Oh, right there. I'm looking for one of the options here. Okay, click quantities. The graduated colors of the quantities method is highlighted. Dialog box is changed. The value list shows available attributes as numerical fields only. In the fields frame, click the value arrow and click Burgo2. It says the Burgo2 attribute represents burglaries for each county in 2002. By default, the values in the Burgo 2 field are grouped into 5 classes using natural breaks, Jenks classification method. That's what you see down here. It says if your color map ramp is different than one previous graphic, click the color ramp and click the blue light to dark ramp. That's not very useful. Oh, to find it by name, right-click the color ramp color bar. And click graphic view to turn off that view.
Yeah.
Okay. Looks like I chose the blue light to dark. Chose the right one. Click OK to close that. See, it's the graduated color symbology is applied to the map. Table contents updated to show the values represented by each color. Light colors represent fewer burglaries, and the dark colors represent more burglaries. How come there's so few up here in North Texas?
Oklahoma had one of the biggest. There's the biggest drug bust in Minnesota. This is burglaries, but they're still both illegal crimes. I don't know. Maybe it's because they're coming from the ocean. Crimes. I'm trying to think of like a good explanation for that, but I honestly can't think of one. Because if it
There's not many people up here, is there? Where do you have more crime typically?
in Dallas,
Larger cities? Yeah, so large cities. I don't know. I'm not familiar with Texas. I couldn't tell you what the larger cities are here, but yeah, oftentimes you see that. Okay. It says the class with the highest values has just 2 members, Dallas and Harris counties. Well, it's a pretty good guess that Dallas is where Dallas is located, right? Harris, I don't know. Next highest class also has 2 members, Tarrant and Bexar counties. Tarrant has one of the larger community colleges, or not a larger, but a large one down in Texas. So I'm assuming it's near a big town.
32 bucks.
And table of contents, open the properties of the counties layer. And click the symbology tab if it's already active, which we have. In the classification frame, click the classes arrow. And we want to change it to 3.
Yeah, if you just type in 3, it changes to 30, and I click enter, and there's a lot.
Oh, with the breakdowns.
Yeah, there's a lot.
Let's see, no classes. Okay, click apply and move. So I click apply. Move the layers away from the map display. You see it broke down maybe a little bit better. Sometimes if you do too many colors, like 30, then you can't tell anything. But maybe that's more easily identifies the large crime areas. Map reflects the new classification. The highest burglary classes are now contains 4 counties. Many counties that previously belonged to separate classes now are grouped together. Why might these counties have a higher incidence of burglary than surrounding counties? We talked about that. On the symbology tab in the classification frame, click classify. It says classification dialog box contains a current classification method and number of classes. Under classification statistics, you can see the count. That's over here on the right-hand side. Count, min, max, so forth. You may need to scroll to the right to see all the values. In the break values box, down here, the well, in break values box, you can see the upper threshold values that defines each class. Percentage button displays decimals as percentages. Large window contains a histogram, a frequency distribution chart. X-axis shows the range of values, Y-axis count. Vertical blue lines are class breaks. The gray column represents the number of features fall within it. By default, 100 columns are drawn in the histogram, so each column represents 1% of the total range. In a break values box, close the first break at 1564. That's interesting. Mine already says 1564. Oh, just click it. Okay. Many of the gray columns are grouped. Oh, I see what it's doing. When you click it, it represents it down here.
Yeah.
Okay. It says 228 elements. That means there's a high count of counties with fewer than 1,564 burglaries, exactly 228 counties. What's wrong with counts, anyway? Yeah, and it doesn't compare it against population, does it? If you only have 2,000 people in your county and you have 10 burglaries, that's a pretty good percentage.
Yeah.
So it's you can't just go off counts, but they're there. Right-click the histogram near the origin of 0, 0. And click zoom in. If you zoom down another spot in the histogram by mistake, right-click and choose reset zoom, then try again. Your results may look different from what you see in the book there, but you can see a little bit better. If you right-click again and zoom in, you can see a little bit better, and so forth. In the columns box, change the default value of 100 to 25. Probably looking right at it. There it is, columns. Okay, then now each gray column represents 1/25th or 4% of the value range. In the classification frame, click the method arrow, click the equal interval. Class breaks now equally divided, still in 3 classes. This method places breaks so each class has the same range of values. Almost all values fall in the first class. Unlike the natural breaks method with equal interval classification, it's possible to have classes that have no values. In the classification frame, click the method arrow. Choose quantile. quantile method creates classes that have equal number of features. And it says click OK to close classification dialog box. Click apply. Move it away. Okay. On the symbology tab, click classify. The classification dialog box for method, click natural breaks. Jinx. Change number of classes to 7. Click OK. It says before finalizing the map, you'll make some small changes to the class labels to make them look better. In the lower section on the symbology tab, click the label column heading. Oh, there it is. Label column heading. Okay. And click Format Labels. On Number Format dialog box, choose the rounding. Set it to 0. Okay. Because that had all those zeros on the end, didn't it? And let's see. Change it to 0. Select the show thousand separator, so put commas in. Click OK to close the dialog box. You see over here, it don't have the zeros anymore. It says 0, 380. See how the label changes are reflected in the symbology tab, and click OK. So this looks better over here. On your menu bar, click View, Layout View. In the Tools toolbar, click the Full Extent button. It's the world. Layout includes a legend that shows the screen classes created using natural breaks. And then we'll go ahead and save it as in My Data. Put my name on it. And that's 8A. So 8B talks about mapping density. Next exercise, you will continue to create thematic maps for a crime mapping project. In exercise 8A, you saw how crime can be mapped to show areas of high and low burglary incidents by applying different classification methods. However, you know that not all counties have the same population. For example, Dallas is over 2.2 million, and El Paso County has just over 650,000. But which of the two is more densely populated? To answer that question, you need to know the number of people per square unit of area. As long as you have both population attribute and area attribute, you can do this. Simply divide population by area. Okay. Dividing one attribute by another to find a ratio is called normalization. So we want to close that and then open EX08B. This opens a map and layout view. In table contents, there's a single active data frame called motor theft per capita. Has two identical county layers coming from the same data source. You will make a population density map that is overlaid by a dot density map of motor vehicle thefts. On the menu bar, click View Data View. Open the county's two-layer attribute. Population attribute contains the population count of each county, the area square MI attribute contains the size of each county in square miles. Next, you will divide the population attribute by the area square miles attribute to create a ratio population density for each county. Okay, so close the attribute table, which is opened. And then click the Symbology tab after you double-click County's two-layer. Okay, I got Symbology. Under Show, click Quantities. Graduated color is automatically selected. In the fields frame, click the value area, choose Population. Click the normalization arrow. And click Area Square Miles. Set the color ramp to red light to dark. Red light to dark. Natural breaks densification classification method is chosen, and 5 classes are defined. Values are rounded, but decimal places are not consistent. Click the label column heading. Choose Format Labels. Number format dialog box, select the number of decimal places option. Change it to 2. Click OK to close that. Click OK to close the layer. Then it says to select the checkbox next to counties 1 to hide the layer. So we'll uncheck that. The class with the greatest population density has 3 counties: Tarrant, Harris, and Dallas. You can verify that by using the Identify tool. Select the checkbox next to counties 1 to make the layer visible again. Open counties 1 properties. In the Symbology tab, click Quantities, Dot Density. In the field selection, scroll down. And we want to choose MV Theft 02. Motor vehicle theft, I'm guessing. And we want to click this greater than symbol here to add it in. Yeah, murd. What do you think that stands for, by the way? Then what? 94 and 02. I'd guess year, 1994, and then they got another measurement 2002. Okay, the box on the right in fuel selection indicates the incidence of motor vehicles in 2002 will be represented by the dot symbol. Next, you'll change the color of the dot so it has a higher contrast. It's kind of pinkish now, so it's a little hard to see. Double-click symbol next to MV Theft 02. To open a symbol selector, click the color chip and select black. Then click OK. In the background frame, click the line button. And some symbol selector, click the color chip. I guess it wasn't black, was it? Or no, they want and click no color. And click OK. This will prevent the county lines from appearing. Density is calculated frame. Click the horizontal slider. This little blue piece right here. Move it left or right. Preview gives you an idea of what density will look like. And dot value box, change the value to 100. So this dot value down here, I'm going to change that to 100. And then click OK. Dot value of 100 means that each dot represents 100 motor vehicle thefts. In ArcMap, you can also build query expressions to include dot density points or use other layers to act as a mask, to exclude dots or place them in a specified area only. In the next few steps, you will use a masking layer to hide the dot density points. From your Chapter 8 folder, add the Harris Adjacent Counties feature class from the Texas County. Let's see, where's the little plus at? There it is. And then we're going to go to Chapter 8 data folder. And go into our geo database and add the Harris Adjacent Counties feature class. So then I'll click add. Hopefully it works. Yeah, that came in. Didn't we have trouble with that before we did a plus and didn't come in? We had like drag and drop it.
Oh, yeah.
Yeah. Let's see. Zoom in on newly added layers located in the southwestern corner. That's weird. Mine came in as green. Did yours come in as green?
Yeah.
Huh.
I don't think the color matters.
Oh, your feature class may be colored differently from the one in the graphic. You think it would come in consistent though, but it must, like I say, come in different, random. Open the county's one property. On a Symbology tab, click the Properties button. On dot density symbol, properties dialog box, select the use masking. Select adjacent counties, or Harris adjacent counties. Mine's already there. And click the place dots only in these areas. Mine's already selected. Click OK. The options in this dialog box allow you to use a mask to either hide or show dot density points. Click OK again. Turn off the Harris adjacent counties. Okay, so it used that Harris adjacent counties to allow us to specify which dots we want that on, basically. So we can just analyze part of it. And then we'll save our work. So I'll do a file save as, go to my data. Exercise 8C, using graduated and chart symbols. Graduated symbol maps use proportionally sized symbols such as circles or squares represent different ranges of values. This type of data allows you to visualize classifications by means of differently sized symbols, making it an effective visual tool. Charts are also an effective visual communication tool. Pie chart can show multiple sets of quantitative data at the same time. Its overall size can be proportionate to an attribute value, and its divisions or slices can show the composition of several attribute values. For example, you might use it to show how much of a country's population is divided into different age groups. Bar charts are useful in side-by-side comparisons. Okay. This exercise, you'll create 3 more maps for this crime mapping project. First, we use graduated symbols to map the aggravated assault. Second, we use bar charts. Third, we'll use pie charts. So open EX08C. In table contents, open the attribute table of the counties layer. Which one? In the assault. Oh, attribute table. I should read. It says the AGRA SLT, AGRA SLT02 attribute represents number of aggravated assaults. Use a natural breaks classification to symbolize data with five classes. So close the table. In table contents, double click the same counties layer to open its properties. Symbology tab. Click quantities. Graduated symbols. In the fields frame, click the value and choose our aggravated assault 02. Aggravated Agra SLT. There it is. In the symbol column, 5 different size symbols are represented for the 5 ranges. You will change the symbol template to something more appropriate. Click the template button to open a symbol selector. In the symbol selector, click the circle 1 symbol. Click the color chip. And click poinsettia red. Click OK to close the dialog box. Next, you change the background color. Click the background color chip. Symbol selector, scroll down the style library and click the medium yellow symbol. Click OK. Next, you will make the you will adjust the symbol size to make the difference between the smallest and largest symbols more apparent. Change the symbol size from 4 and 18 to 3 and 20. So put 3 here, put 20 here. And label column. Click the 0 through 198, type less than 199. For remaining labels, change a hyphen to the word to. So you just click on them to change them. Then click OK. Map shows the graduated symbols for each county. The table of contents shows the graduated symbol for each county. The table of contents shows graduated symbol settings you made. Similar to the density maps, you create an exercise at EB. Greater number of incidents are located in counties with higher population. You will continue by creating bar charts to compare larceny. Okay, in table contents, right-click the larceny. And click Activate. Table contents, right-click larceny data frame. Oh, not counties. Then choose Activate. Open the counties attribute table. Scroll to the right and you'll see the larcenies column. So there's trying to emphasize that we're doing columns of data in here. And 2 layer attributes represent the number of larcenies for each of the 250 counties. What's the larceny?
I know what larceny is.
Larceny. I don't know what a larceny is. But probably not good. For each of the 254 counties in 1994 and 2002. Again, the 94 and 02 you see. Right-click the larceny column heading.
Larceny is theft of personal property. Wait, doesn't it catch up like
Burglary? Maybe burglary is where you actually break in. Larceny is where you go off to the bathroom and I steal your laptop while you're in the bathroom. I don't know.
Well, it's your laptop.
Okay. Statistics. Gives us that chart. Many of the counties have low counts of larceny. The tallest blue bar in the frequency distribution. As you saw earlier, a majority of the incidents occur in higher population counties. Instead of creating bar charts for each county, you exclude counties that have a low population. Close both the statistics, and the attribute table. Table of contents. Open the properties to the county's layer for the larceny. On the symbology tab, click show, or under show, click charts. Choose bar column. Scroll down the field selection list, click larceny 94. And click the right facing arrow. So we click the add here, click larceny 02, click the greater than symbol again, add both of them. Your bar chart colors are randomly selected, may be different than one in the graphic. Click the exclusion button to open the data exclusion properties dialog box. Click the query tab and the exclude clauses list. Double click population. It adds it down here in our build. This is a SQL query, by the way. Let's see. Press the space bar. Space bar is we're editing this down here, this SQL query. And then type 500,000. Yeah. In the expression box. Do not use a comma. You just constructed a query that excludes counties with a population less than 500,000. I think I missed something. Okay. Click the less than 500,000. That's not a valid query, population 500,000. So we got to have a less than in there. Okay. On data exclusion properties dialog box, click the legend tab. So we'll go to legend. Select the show symbol for excluded data. Click the symbol color chip. And choose grade 20%. Oh yeah. Click the fill color chip. If I could read. 20%. Then click OK. In the label box, type population less than 500,000. Click OK. Click the properties button to open the chart symbol editor. In the bars frame, adjust width to 10. And click OK. Click OK to close layer properties. Bar charts are drawn on the map for the counties that were not excluded. Next, you create a final map to show all the crime attributes included in the 2002 dataset. So those charts mean anything right there?
They represent the value.
Does that mean crime's increasing?
Yeah. Or it has to increase. Doesn't mean it's increasing necessarily. I mean, it's like old data. So you'd have
It's old data.
Yeah, you have to compare it to 2018.
This is the number of larcenies. Has a number of people increased in Texas? It has, hasn't it? So you don't really look at counts, you look at percentages. This looks like it's increasing in the crime there, which the number is increasing. There's no doubt about that. But again, it's the percentage of the population. You know, what percentage of the population's having a larceny committed against them? That's what's really more important. Okay. Bar charts are drawn on the map for the counties that are not excluded. Okay. Next, we'll create a final map. So activate the all crime data frame. So right click on it, and you choose activate. Open the properties of the data frame's counties layer. On the symbology tab, under show, with charts. Pie chart is highlighted. In the field selection, choose aggravated assault 02. Aggravated assault 02. Click the right facing arrow. And then continue to add the following: arson 02, rape 02, my theft 02, murder 02, rob 02, burglary 02, larceny. I'm guessing all the 02s.
Yeah, it was 2000.
Yeah. Maybe I'm wrong. I'm wrong. Okay. Arson 02, rape 02. Motor vehicle theft 02, MV theft 02. Murder 02. Rob 02, burg 02. And larceny 02. It's almost all of them. Right click the color scheme map. And click graphic view to turn off that view. And then click the color scheme and click enamel. Symbol color is random assigned to each attribute using the selected color scheme. Similar to the bar charts, you include some values and change the size of the pie charts. Click the exclusion button to open data exclusion. Properties dialog box. Click the query tab and exclude cross. Double click population. So go to query, double click population, and then we want less than 500,000. Click the legend tab. Click show symbol. Click symbol color chip. Click the fill color. Click gray 20%. Click OK. Label box. Type population less than 500,000. Click OK. Next, click the size button. And a pie chart size dialog box, the vary size. Vary size using the sum. So second one. Adjust symbol size to 20. Select the appearance compensation Flannery option. Then click OK. Size of each pie chart will be based upon several factors: the numeric size in points, the variation due to the sum of the attributes value, and the appearance compensation option. When compensation is activated, ArcMap scales up proportional circles, in this case pie charts, so that the larger the circle, the greater the amount of scaling. Compensation of proportional circles was a major research focus of James Flannery, a professor of geography specializing in cartography in the 1950s. And select OK. The menu bar view, layout view. With CR3 we selected. So go ahead and
If you want that yellow one to be bigger, like it is in the book, if you click on the salt data frame, or if you right.
Oh, it is bigger in the book. I didn't even notice.
If you right click on it, then you click activate, and then in your bookmarks you click main, and it makes it bigger. Like the table of contents.
Oh, table of contents. That was the aggravated assault?
Yeah, just assault, and then activate, then bookmarks, and main.
And you can save that as, and go to My Data. Save it there. Now I want you, the assignment, I want you to open up, go ahead and open up Hayes, or not Hayes, go back one. Open up EX08C. And I want you to create a different chart. Different options and so forth. Do the same type of thing. For the, let's see, properties. For the symbology, you got your charts, your exclusion, your query. Choose a different value than 500,000 and see what you can do with it. Only look at small towns, less than 50,000 or something like that. But yeah, the rest of the time for that.
Do we have